All right, so this screencast is on Igneous Rocks. Again, as I said before, it'd be ideal to have the samples in front of you, but that is not the case. So we're going to run through the two main ways of classifying igneous rocks, a few other aspects of igneous rocks. There is not really a great assignment to go along specifically with igneous rocks, but along with this, I'm going to have you do the rock classification gizmo over on explorelearning.com. All right, so into igneous rocks. So two main ways of sort of looking at what is going on with igneous rocks in terms of how we might classify them. One is on the size of the crystals that form the igneous rocks. So when we talked about sedimentary rock, we talked about grain size and how coarse it is. Here we're talking about crystals, and this is how igneous rocks relate to minerals, because those minerals, they're growing as crystals, and it's those crystals that we're looking at here, right? So we're looking at the size of the crystals, whether they're small, sort of fine-grained, or larger, coarse-grained crystals. And then second is really the mineral composition, but we could kind of get around that and look at it as color, and there's a couple of categories there, really kind of four categories, but two main ones, sort of light colored and dark colored, although those are subjective as well. So the first thing we're going to look at is the cooling rate. And this really is the texture. So again, this is how big the crystals are that make up the rocks. These tell us something about how fast or how slowly the rock formed. Okay, so think of baking something, baking brownies in the oven. The question here is whether you would start that batter, put it in the oven, and leave it in for, let's say, 15 minutes, and then either turn the oven off and leave it in the oven, or turn the oven off and set it out on the counter. Right, so the one that's out on the counter is exposed to the air. It's going to cool quicker. They both were hot in the oven, but the one that is now subjected to the air is going to cool quicker. The one that stays in the oven is going to stay, even though the oven's off, stay warm, and it's going to cook longer, right? And so the same thing is sort of happening with the crystals. So there's a lot on the slide, a lot of different terms I want to point out, but here we're looking at large crystal sizes. And so there's a little piece of granite here in the picture. And this is called a phaneritic texture. It basically means large crystal sizes, right? And so these crystals had a long time to grow, which means they cooled slowly. This is like the brownie that stayed in the oven, right? And so it cooled within the oven, or within the earth in this case. And so we call these intrusive igneous rocks. Okay, so intrusive igneous rock cools slowly within the earth, and it forms these large phaneritic crystal sizes, right? So phaneritic texture. Okay, so examples there. Granite that's shown here is the ideal picture. All right, on the other end of the spectrum, then the next slide are the brownies that we take out and we set on the countertop. These cool quickly, right? Started off hot, but now they cool quickly. These cool on the surface of the earth. They're now exposed to the elements, and so exposed to the atmosphere. They're going to cool down quicker. They've got an aphanitic texture, meaning smaller crystal size. This is stuff that's lava on the surface, whereas the previous slide we were talking about magma, which is deeper within the earth. Right? And so these have a fine crystal grain size. The best example of that is obsidian or volcanic glass or volcanic lava. All right, so aphanitic texture, very small. These cool quickly. They are forming extrusively or on the surface of the earth. Okay, so to look at that, we can look at that here as an image of what would be going on interior of the earth. We have some magma. On the exterior of the earth, we have lava. When that lava cools, even though it might be the same material that's cooling, we have an extrusive igneous rock that's forming with a fine-grained crystal. The intrusive igneous rock from the same material would cool in intrusive igneous rock with a larger crystal size or more coarse-grained crystal size. And now this slide shows sort of a little bit of both of those things happening. This is called porphyry. And here we have large crystals that you can see embedded in this matrix of smaller fine grain. material. So these start to cool intrusively as magma in a magma chamber, and then as it moves towards the surface, it starts to cool quicker, and this matrix forms around. So it's a little bit of both. It starts to form with large crystals, and then it gets embedded in this matrix of smaller crystals. Okay, so that's porphyry, a little in between of both intrusive and extrusive igneous rock. All right, and then the other way to look at it, as I said, is what it's made out of. And the two main categories there are felsic and mafic. The easy way to remember that is I have at the bottom here, felsic are lighter in color, and so the L in felsic goes with lighter in color. The mafic generally darker in color. Now I say generally again because if you look up again here, what we're talking about is the minerals that make them up. Okay, so these are different categories. So there's felsic, mafic, and then sort of this intermediate between the two, and then ultramafic, excuse me. And we can kind of best see that in a couple of different charts and representations. All right, so bringing all that together, here we have, again, our cross-section of the interior of the Earth. We have intrusive rocks and extrusive rocks. We have things that are ejected very quickly, right? And so they're going to cool very quickly, and so these would be extrusive. And then we have things that cool very slowly, and these would be intrusive, right? And then we have our mafic and our felsic. Okay. So really what this is saying, the same material, the same magma, the same stuff that's in the magma, if it cools slowly, it forms granite. If it forms quickly, it forms rhyolite. Okay, so these two are related, rhyolite and granite. One is intrusive, one is extrusive. Right? Rhyolite, extrusive, granite, intrusive. Same thing with the mafic column here. Same material. If it cools more slowly, it forms gabbro. If it forms quickly, it forms basalt, even though it starts off as the same material. All right, and then there's that porphyry that we talked about, which is a mixture of the two, starts to form these large phenocrysts intrusively, and then as it moves towards an extrusive environment, it forms that matrix around it that's much smaller. Okay, again, just like we talked about with sediment size, there are different terms that we might use to sort of describe whether it's a glassy fine grain like the obsidian that I talked about, or kind of very coarse grain kind of stuff like we see in the granite. All right, that brings us to this Bowen's reaction series, which I'm going to briefly talk about now. Basically what Bowen did is he found that if you heat up this magma and leave it at a very high temperature and cool it at different temperatures, which seems odd to think about when you look at this graph. If you cool it at 1200 degrees, it's still going to cool. Okay, that's very hot, but that magma is still going to cool. Or you can cool it at a lower temperature, 600 degrees. Basically what he found out, if you take the same material and cool it at these different temperatures, leave it at that temperature steady until it cools to form a solid, it'll form a different rock. Okay, even though it's the same mixture of material, depending on the temperature at which it cools, it'll form different stuff. And that is really Bowen's reaction series. And there's two sides to it. There's this continuous side, which basically you start with 100% calcium-rich feldspar and moves up towards 100% sodium-rich. So at about the midway point, it's 50% sodium, 50% calcium. It's always this 100% of these two things combined. Okay, so you start with 100% calcium, and then it slowly fades into 100% sodium. On the other side of Bowen's, what he found is this, what we call the stepwise reaction series, where olivine forms first, then after that pyroxene, and then amphibole, and then mica, and then quartz, muscovite mica, and finally feldspar. Now these might sound familiar because these are minerals, and you may have looked at some of these minerals. All right. So there's a lot going on here. Give you a moment to digest it. You might want to pause and look at it for a second. Here we have our felsic category, intermediate, mafic, and ultramafic. Okay. At the top, we have examples of both intrusive and extrusive igneous rocks. Okay. So, for example, there's the ones that we talked about earlier, basalt and gabbro. Right. So they are made of the same material. And here it is right here. So if you find a sample of basalt, want to know what's in it, it's got a little bit of olivine, a little pyroxene, a little bit of amphibole, and calcium-rich plagioclase. Okay. So that same material, again, if it forms intrusively, forms gabbro. If it forms extrusively, it forms basalt. Come over to the felsic again. There's too many here for me to list off, but you can read through them all. All these minerals listed in here in different amounts, as it says over here, are formed to form both granite or rhyolite, depending on whether it's intrusive or extrusive. Okay. And there's our felsic. And over here, mafic. So you can see down here, this band goes to increasingly dark. And then silica content, not as important to us, but sodium and potassium and some other minerals or elements, calcium, iron, and manganese. So Bowen's reaction series gets at this a little bit. The next slide shows this as well. The mineral composition and the rocks that they form and whether they are intrusive or extrusive. Okay. So coming back to Bowen, basically what he found is that if we have this magma chamber here, the first thing that happens in this stepwise fashion is everything that needs to form comes together to form that first olivine at the bottom of Bowen's reaction series. So olivine crystallizes, it forms, and it settles out of the magma and drops to the bottom, which we see here. Oop, click over here for my slide to advance. All right, so olivine forms, and then what happens next? We go up Bowen's reaction series. Pyroxene starts to form. It falls out to the bottom. Then plagioclase feldspar forms. It falls out to the bottom. And so what we have is almost these layers that start to form that might look like sedimentary rock layers, but it's forming these, it's an igneous rock made of these different chemical compositions of minerals. Right, and so on and so forth as the temperature goes, as you can see here, from the 1200 degrees Celsius to 600 degrees Celsius. So that is how these palisades in New York form, this exposed area that you can now go and visit. You'll see that although it's between two layers of sedimentary rock, sandstone, we have this basalt layer, and then as we go up, we're basically seeing Bowen's reaction series play out here in this picture. And so that's kind of an interesting part that a lot of people will go and explore to see this sort of demarcation of different minerals that form, again, from the same magma. All right, so as I said, there's not a great activity to go along with just igneous rocks, but the rock classification gizmo goes along fairly well with this, give you some exposure to it in terms of the extrusive and intrusive igneous rocks. So go ahead and work through that, and that will be the assignment that goes along with the igneous rocks. All right, and then we will meet up to go do a Blackboard collaborative. So if you have any questions, make sure that you note those so that we can talk about those when we get together in the Blackboard Collaborative Ultra. All right, see you then.